go.
Yes.
So welcome to another live session at Atlantic International University. Today's date is the 17th of February. My name is Dr. Edward Lambert, and our presenter today will be Rabia Liaquat, who is going to be talking about Anova, the use of Anova in statistical analysis.
So can you see?
Yeah, we can see, we can still see all of the menu up above by clicking on that little hat over here. You can actually make all that menu stuff up above disappear. Do you see over there on the right where I circled it with a blue circle?
Right?
Yeah. Are you able to click on that little hat?
Yes.
Okay.
So today our topic is Anova. What is Anova? Anova is actually the pronunciation with analysis of variance. So an Anova test is a way to find out if survey or experiment results are significant. In other words, they help you to figure out if you need to reject the null hypothesis or accept the alternative hypothesis. So here three things are coming: significant, null hypothesis, and alternative hypothesis. So what is significant? This is a way to tell you if your test results are solid or not, or weak. So null hypothesis, which is denoted by H0, and alternative hypothesis, which is denoted by H1. The null hypothesis can be thought of as a nullifiable hypothesis. That means you can nullify it or reject it. What happens if you reject the null hypothesis? It gets replaced with the alternate hypothesis, which is what you think might actually be true about a certain drug might be responsible. Drug company thinks is a natural hypothesis which always exists. So in this example, the drug is on the market, people are using it, and it's generally accepted to be safe. Therefore, the null hypothesis is that the drug is safe. This is our null hypothesis, initial hypothesis. Drug is safe. The alternate hypothesis, the one you want to replace the hypothesis is that the drug is not safe. This is hypothesis, and can you hear me? Kindly confirm.
We can hear you, but sometimes your sound is not recognizable. We can't really hear very well. But go ahead, because we can read your presentation.
Okay. So here we will discuss the types of ANOVA. There are two main types. One is one-way ANOVA and the second one is two-way ANOVA. Two-way ANOVA tests can be with or without replication. So what is with and without replication we will discuss in these lines.
Can you change the slide to the next slide?
Okay.
You might have to go to the presentation mode.
Can you see?
We're still on the very first slide. We don't see
Okay.
the second slide yet.
This is the first slide. Then this is second slide.
There we go. Now we see it.
So here we will see the types of ANOVA. There are two main types of ANOVA, one-way and two-way ANOVA. Two-way tests can be with or without replication. One-way ANOVA between groups used when you want to test two groups to see if there is a difference between them. Two-way ANOVA without replication used when you have a one group and you are double testing that same group. For example, you are testing one set of individuals before and after they take a medication to see if it works or not. Two-way ANOVA with replication with replication, this is without replication. So two groups and the members of those groups are doing more than one thing. For example, two groups of patients from different hospitals trying to different therapies. So these are the types of ANOVA, one-way ANOVA and two-way ANOVA with presentation. So one-way ANOVA, the simplest one-way ANOVA can be thought of as a generalization of two sample t-test. So one-way ANOVA involves testing the omnibus hypothesis that K population means are identical. So first I will clarify the concept of mean. For example, we have a set of numbers. So I want to calculate its mean. So I will add all numbers and divided by total number of observations 1, 2, 3. So the answer will be a mean. Can you hear me properly?
Yes, I can. I can hear you.
So here is the concept of mean, where number of observations divide. We will add all observations and divide by total number of observations. So this is the concept of mean calculation. So in this one way in our test, we have null hypothesis that all means are equal. So for example, we have 2 or 3 or 4 groups. So we will calculate the mean of this one, this and this, and we will observe that all means are equal or not. If they are equal, then we say null hypothesis satisfied. So if we have only two groups, for example, only two groups, then we apply t-test. If we enhance the number of groups, then we will move towards ANOVA test, and this is one way ANOVA. So note that the two sample t-test tested the hypothesis that two population means are equal. K is equals to 2 means if we have two populations, then we apply t-test, but if we have more than two populations, then we apply ANOVA test. So the alternate hypothesis for ANOVA states that any one of the population mean equalities does not hold. For example, we have 4 groups. So we will, if we prove at least one mean is not equal, so we can say the null hypothesis rejected and alternative hypothesis accepted. It is important to note that a rejection of the null hypothesis does not tell you which of the population means different. So we cannot we cannot see which one population is different mean, has different mean. It only tells you that there is some population whose mean is different from at least one other population. It could be that all of the means are different from another. Okay. So next one is, what is the formula of the one-way hypothesis? Is F is equals to MST over MSE. What is MST and what is MSE? So MST stands for mean sum of squares due to treatment. MSE stands for mean sum of squares due to error, right? So here is the formula based. So in one way analysis of variance, we have only one factor, right? So one factor we will DF means degree of freedom. And what is degree of freedom? Degree of freedom is the number of independent pieces of information on which the estimate is based. So degree of freedom, we will calculate the degree of freedom. SS means sum of squares between the groups, right? MS means mean of square. F is the ratio, Anova coefficient. So from F distribution with m minus 1 numerator and n minus 1 m denominator degree of freedoms. So here we have two degree of freedoms, like V1. We will show that V1 is the degree of freedom of numerator, and V2 is the degree of freedom of denominator, right? So for example, we have and alpha is the level of significance. For example, I will calculate the level of significance 0.01. So so we will check this one in the table, which will be provided online. So we will put 0.01 and the degree of freedom. For example, we have 4 and 10, right? Can you hear me?
Yes, yes, we can hear you.
Okay.
The sound
Okay,
is coming through fine now.
Okay, so let me tell you. Can you see the table of F distribution?
Yes.
This one.
We see right now the formula.
Yes. For example, we have a level of significance 0.05 and the degree of freedom of numerator. This is the table of numerator degrees of freedom, and this is the denominator degrees of freedom. So this is level of significance with alpha is equals to 0.05. So I will check 4 into 4 numerator and 10 denominator. So I will go this one, and this is 3.478. This value will come. So back to the presentation. So this is how we can check the table of Anova coefficient, right? So one and two way ANOVA. A one-way ANOVA is used to determine how one factor, here we will discuss only one factor, impacts our response variable. For example, we might want to know if 3 different studying techniques lead to different mean exam scores, to see if there is a statistically significant difference in mean exam scores, we can conduct a one-way ANOVA. For example, we have only one way. The response variable is exam scores. So here is one factor and this is response variable, right? While in two-way ANOVA is used to determine how two factors. In two-way ANOVA, two factors will be involved: level of exercise or gender, right? A response variable, and we will check the response variables of two factors. Here only one factors. Note there is an interaction between the two factors on the response variable. For example, we might want to know how gender and how different levels of exercise impact average weight loss. We would conduct a two-way ANOVA to find out. So here I am going towards four-way ANOVA. A four-way ANOVA is a factorial ANOVA unless you are thinking of some other meanings for four-way. Each factor represents one variable. So every factor has only one variable, a set of categories or treatment types or treatment dosage. Here is an example. Here we have four factors. So this is four-way ANOVA. So factor one is sex, female or male. Here we divide this factor into two groups or levels. We can say groups or levels, right? So second factor is drug doses: low, medium, and high. So here we divide two factors into three levels or three groups. So the next factor is age factor. So young, middle aged, or old. There three groups or three levels. We divide the factor 3 into three groups or levels. Similarly, psychotherapy, yes, no, two groups. We divide it into two groups. In a factorial design, you examine every scores on an outcome. In an factorial design, you examine every scores on an outcome variable such as anxiety for all possible combinations of groups or levels. In this example, you would have to multiply. We will multiply all levels: 2, 3, 3, and 2. Here we multiply all levels, and we will find number of different combinations. So one combination of condition would be male. Here we will choose male. Second one, I will choose low drug dosage. Low drug dosage. Third means middle age, and no psychopath therapy. So here is the data I select from the factors and levels of groups or groups. So if you want to have at least 10 people for each combinations of conditions, you would need to you would need this and multiply by 10. If I choose the data of 10 people from the 36 different combinations, then I will multiply from this with 10, which is 360 people total. So total number of people, the data which is is 360 people. Usually the main point of a factorial design is to evaluate interactions. For example, does increasing the drug dose have a different effect on the outcome for males versus females? It is very common to have two-way factorials and fairly common to have three factorial design, but it is very rare to have four or five-way factorial. You begin to need a very large number of people to fill up all the groups, and the interaction among multiple variables start to occur. Case for four-way ANOVA. So usually we will talk about one-way ANOVA and two-way ANOVA. We will we will discuss one way and two way. Today our main focus is one way ANOVA. So so I will show how let me so can you see Excel sheet?
Yes, we see your Excel sheet now.
Okay. I will show you how we calculate one way ANOVA in Excel sheet. Let me enter the data. This is a data of rows.
It appears as though, Rabia, are you here? Rabia Liaquat, are you here? We see you working, but we don't hear you. I'll go ahead. I'll go ahead and talk while you work. So for each group, rope A, rope B, rope C, rope D, and rope E, she is putting in the data from those groups. And so that data represents a level of an outcome. It represents an outcome. And so each participant in those groups produced an outcome. So let's say that you had different types of food, and each one of those foods showed a different resistance to drought. You could give a level to that resistance of drought.
Yes.
And so let's say like in rope E, you have a type of food, but you have 4 plants, and you're giving the score for each plant. So keep going, Rabia. We are following you. Even though we can't hear you at the moment, I'm kind of explaining. And that you have 5 groups and 4 participants in each group.
Yeah. Can you hear me?
And yes, now we can hear you.
In this example, we have 5 different rows.
And within each group, you have 4 participants. And each participant gives a result. And so you write down your results from each of those participants.
Can you hear me?
Yes, now we can hear you. I'm helping to explain.
So in this example, we have 5 different rows, A through E. Okay. Yes. And each row. Yes.
And so that's the strength it takes to break that rope.
So let me draw its graph.
Okay.
So yes.
So she will
Okay.
draw a
Before
graph.
conducting any always examine your data graphically. So I will graphically me. So this is yes. The yes. So let me add the label axis of breaking strength breaking on the x-axis or horizontal axis. I will types come from a normal distribution with a population mean that is the same. In other words, I have got my
So you can see 5 lines in the graph. Each line represents one of the ropes. So you can kind of see which rope is the strongest and which rope may be the weakest.
For rope A through E. So I will try.
And each group will have a mean or an average to its results.
Examine the all groups coming from normal distribution. Let me write what is normal distribution.
So you get a sense right now of what the average
What
is
is normal
for each group.
distribution? Normal distribution is the curve. So here is the normal. Yes, yes.
So as you can see, the data is simple. You have different types of rope, and you're seeing how much strength it takes to break that rope. So it's a simple experiment because you're just taking the rope and breaking it 4 times each time.
So here
And
is
you're getting
normal.
an
There is
average
no
from that.
skew symmetry. Distributed is negatively skewed. So we are normal, then all
So right now she is checking for the skewness of the data to see if it's normally distributed. And there are tests to do that are simple to use in Excel. And you can just grab the data, put it into a little formula, and the formula will tell you if it's normally distributed.
It is possible that these.
And if the data is normally distributed, then you can use it. If it's not normally distributed, you might have to use another test to analyze the data. It's another type of Anova test. Oh, I think we lost the speaker. Yes, the connection was unstable. So you can see in the presentation there that there were 5 ropes, And those 5 ropes were tested 4 times. Each of those 5 ropes were tested 4 times. And that gives you an average of what the strength it takes to break that particular rope. So it gives you an average, a mean. And then the Anova test will actually compare those means to see which one, to see if they're different, basically. Anova will tell you if they're different, but it won't tell you which one is different. You'll have to use another test to actually determine which one is different. Statistically speaking, which one is different. And when it means statistically speaking, it means that at the rope, the difference has to be great enough to be significant beyond statistical probability. And so once the Anova test says one of these ropes is different, significantly different, then you can
Now you
figure
can
out
see
which
the
one.
Excel sheet.
There you go. We can hear you again. You're back on.
Okay.
But I think you're
So
muted.
here we
You were muted, but we can still hear you.
so are you hearing me?
Yes. So we do not see your presentation anymore. That disappeared.
Okay.
But we do hear you.
Let me share again. Yes.
Because we want to see you run the results through Excel. We want to see that.
Okay. Can you see the
Not yet. We do not see anything yet. You are co-host, so you can share your screen.
Okay, let me try again.
Okay.
I think there is a connection. I think there is a connection problem.
It really is so fun when you have your data and you just start clicking some buttons in Excel to get all the results. You don't have to do the formulas yourself. The Excel or your other software for statistics does the calculations for you. And it's so fun to see the results.
Okay.
Like I know some students are actually working on herbal remedies for COVID. And so they can actually do tests with their treatments against other treatments for COVID and get
So I am in good analysis.
If their herbal remedy
Can
is
you see?
significant. Yes.
Data analysis.
Yes, we see the data and we see the chart. We do not see the analysis yet, though.
We are, yeah. So here we are. So the input range will be from E. Here I choose the data. These are column wise data we calculate, and the label 0.05 significant level. So output range, let me J1. Okay. I select the data here, and this is let me
I am going to be
Okay.
putting, I'm going to try and put a book in the chat. Let me see if it might be too big. Let me see.
Can you hear me?
Yes, we can hear you now. Yes.
Okay, okay. So this is the ANOVA single factor. So we calculate
Rabia, go ahead and just continue. We will watch what you do. Just go ahead and continue with your work. We cannot hear you, but we can see what you're doing. And I just put into chat a good book. It's one of my favorite books on statistics. It's 35 megabytes, so hopefully you'll be able to download it.
So I got rows A through E, my analysis of variance table shown here, and usually what I find most useful is the p-value. P-value. We check the p-value. 0.0076564, which is less than the significant level 0.05. Our significant level was
We don't see the analysis yet on the screen. At least I don't. Does anybody else? No. I have a question in chat of how you can actually draw graphs and insert them into a Word document. It is so easy. You just grab your chart, you click on your chart, Control C to copy it, you hold down the Control key and the C key on your keyboard, Control C, that copies it.
Yeah.
Just go into your Word document, put your cursor where you want it, push Control V. Hold down the Control button and push V, and that will paste the chart directly into your Word document. Super easy.
Okay, okay.
Okay, we can hear you, Rabia. Go ahead.
Okay. Let me open the Word document.
So you can see she's right now picking out the Anova single factor test from Excel. Then there's the result. She grabbed the data in that little box and pushed the button to do the results, and there are the results. And then all you have to do is look at these results. Go ahead, Rabia, can you speak?
Yes. So
Okay.
you can see the results.
Yes, yes, we can see the results. And the p-value is very low.
Important. Okay. Yes.
That's the first thing you want to look at is the p-value, right? Would you agree, Rabia?
I don't. Yes. Yes, yes. Here, usually what I find most useful is the p-value.
Is the p-value.
In this case, we find a p-value of 0.0000764. Yes, which is less than our alpha of 0.05, level of significant 0. Right?
I'm looking to see if it shows the critical, if it shows the 0.05. I don't see that anywhere.
And this gives us a good indication that we could reject the null hypothesis, and it gives us a good indication that at least one of population mean is different from the other, and we will look at the data graphically. It does appears the rows C and D are weaker than rows A and B. So this and this are weaker than row A, B, and E, and is this what causing the this relatively low
So rope C and rope D look relatively low
So
compared to the others.
yes, it's not rejected and it's when accepted.
And because the p-value is such a low number, below 0.05, it shows that it really is significantly lower. And so you can just grab that data, just select that data, push Control C to copy it, go into your Word document, Control V, paste it right in, and then talk about it in your assignment or even in your research paper. It's that easy. The statistics does not have to be complicated. You just grab your data, do the result, and talk about it.
Yes.
But as Rabia was doing earlier, she was checking on to make sure that the data was normally distributed. That's an important part of a professional research paper, is you want to make sure your data is normally distributed. Rabia, go ahead. We can hear you, I think. Rabia Liaquat? Can you speak? No. So as you can see in this column here for the average, right there, that is what the Anova test is calculating, the difference between those averages. And if one of those average is significantly different, then the Anova test will say one of these ropes is significantly different than the others, or two of these ropes are significantly different. So we have lost connection with the speaker, but you get the idea. And you'll see that in that p-value, if that p-value is below 0.05, one of those ropes is significantly different. Either it's very strong or very weak compared to the others. And that helps you identify which is the best rope for what you want to use it for. So let's say you're doing crops for a certain, say, corn or another crop, and you want to see which of these different types of corn can resist drought. So you plant maybe 100 plants of each type, put them into drought conditions, and then record how much corn you receive from each plant. And so then you just put out the data, how much corn did you receive? Maybe in pounds or kilos, or even if you wanted to count the seeds, you just develop a number that you're going to evaluate, put that in for each corn plant, you develop a number from each of those 100 plants from each type of corn. And then, as you can see, you just run that data, you run those numbers down in columns, grab it, push a button, within 30 seconds, you have your results. But it may take you a whole year to get the data growing the plants, but within 30 seconds, you have the results. It's that easy. And then you write a paper on it and say, according to these drought conditions, these plants were the best. And they were significantly different. That's what you want to look for, that they were statistically different, significantly different than the other plants. And then you publish your paper, and you just improved food production in your country because you did the experiment to show which of these plants does the best. Hey, Rabia Liaquat is coming back. So now she's going to talk about normal distribution. This is important.
Yes. Normal distribution where mean, median, and mode all lies in the center. Right? No, you hear me or not?
So in the normal, we can hear you. Go ahead and talk about normal distribution.
Okay. This is the normal distribution graph where there is no any skewness, no negatively skewed, no positively skewed, or no skew. Only mean, median, and mode are on the center of the data. So the normal curve represent a perfectly symmetrical distribution. Next, we will talk about the applications of ANOVA. So ANOVA calculation in fertilization, a large-scale firm is interested in understanding which of three different fertilizers lead to highest crop yield. The sprinkle each fertilizer on 10 different fields and measure the total yield at the end of the growing season. To understand whether there is a statistically significant difference in the mean yield that results from these three fertilizer research can conduct a one-way ANOVA using type of fertilizer as the factor and crop yield as the response. So here is the factor and here is the response rate. If the overall p-value of ANOVA is lower than or significant level typically chosen to be 0.1, 0.05, 0.01, then we can conclude that there is statistically significant difference in mean crop yield between the three fertilizers. So here we can calculate ANOVA in fertilization. Next, similarly, we can ANOVA calculation in medical researchers. Similarly, the same method. Medical researchers want to know if four different medications lead to different mean blood pressure reductions in patients. They randomly assign 20 patients to use each medication for 1 month, then measure the blood pressure both before and after the patient started using the medication to find the mean blood pressure reduction for each medication. To understand whether there is a statistically significant difference in the mean blood pressure reduction that results from these medications, researchers can conduct a one-way ANOVA using type of medication as the one factor and blood pressure reduction as the response. In the same way, we can calculate all these things in the Excel sheet. So if the overall p value of the ANOVA is lower than or significant level, then we can conclude that there is a statistically significant difference in mean blood pressure reduction between the four medications. So the important thing is p value and level of significance. We just compare the value p value and level of significance. If level of significance is greater than less than p value, then a is not accepted, otherwise a is not will be rejected. Same thing for calculation in advertisement. Same formula apply in the advertisement. Here you can read out how we can calculate ANOVA in advertisement.
That's a good
Biologist,
example where you're seeing the result of each type of advertisement to see which one's more successful, correct?
yes,
That's beautiful.
yes. So here advertisement affect mean sales differently. So here we can also use ANOVA test, right? Next is biologists also used ANOVA. How they can use? Biologist wants to know how different level of sunlight exposure, no sunlight, low sunlight, medium sunlight, high sunlight. So there are 1, 2, 3, 4. There are 4 levels or groups. And watering frequency daily, weekly. This is the second factor. This is the first factor. This is the second factor, and these are the level or groups. And this is the second one factor. And this daily, weekly. This is the level or groups. Impact the growth of a certain plant. In this case, here we will use 2 factors are involved: level of sunlight exposure and water frequency. So they will conduct a two-way ANOVA because there are two let me write here. There are two factors. One factor is sunlight exposure, and the second one is watering frequency. And the two factors involved. So here we will apply two-way ANOVA to see if either factor significantly impacts plant growth and whether or not the two factors are related to each other. The results of the ANOVA will tell us whether each individual factor has a significant effects on plant growth. Using this information, the biologists can better understand which level of sunlight exposure and or watering frequency leads to optimal growth. Usually in two-way ANOVA, we can see the relationship between factors. In one way ANOVA, we independently calculate the factors and calculate their means and compare them. But in two-way ANOVA, we build up a relation between two factors. So this is the main difference between one way. In one way ANOVA, only one factor involved. In two way ANOVA, two factors involved. In three way ANOVA, three factors involved. Similarly, in four way ANOVA, four factor will be involved. And in one way ANOVA, we calculate every group or every group independently and calculate their mean. And then at the end, we will compare the means. If the means are same, then it will be null hypothesis accepted. If not same, then the null hypothesis rejected. In the two-way ANOVA, we will build up a relation between two factors. So the next is conclusion. ANOVA is used in a wide variety of real life situations, but the most common include retail. Includes retail. Stores are often interested in understanding whether different types of promotion, stores, layouts, advertisement tactics, etc. lead to different sales. This is the exact type of analysis that ANOVA is built for. So in the medical researchers are often interested in whether or not different medications affect patient differently, which is why they often use one-way or two-way ANOVAs in this situation. Similarly, in the environmental sciences, researchers are often interested in understanding how different levels of factor affect plants and wildlife. Because of the nature of these types of analysis, ANOVAs are often used. So this is the conclusion of one-way and two-way ANOVA test. So in the business context, ANOVA is also very helpful. ANOVA is widely used across businesses and industries for a variety of purposes and is a technique that enables companies to identify problems, trends, risks, and opportunities that impacts both. Below are just a few of its many applications within business scenario. So quality and cost comparison. In the automotive industry, a car manufacturing company can use ANOVA when purchasing materials to compare the quality of the material to the cost so that they know which supplier to buy from or who should build their products. For example, if they need to purchase steel for door frames, they can compare the strength of the steel to how much it will cost to purchase. Similarly, in the business context, product safety test. In the beauty industry, cosmetics companies can use ANOVA to test the safety and effectiveness of certain makeups or sunscreens products. For example, they can evaluate these products across different group of people and then choose to use the ingredients that provide the desired outcomes while minimizing health risk. So more applications of ANOVA: optimize production. In entertainment and media companies, companies can use Anova to test what different locations for filming and upcoming movie and determine which site would be best based on the time of the year or how much materials would cost for building a set, enabling them to choose the most cost effective production company. In the healthcare industry, we can use the Anova test to compare different medications and the effects on patients. Anova also helps to manage budgets by comparing your budget to cost to help manage revenue and inventory. For example, Anova can also be used to forecast trend by analyzing patterns in data to better understand the future performance of sales. So basically, Anova is simple. The comparison of means, analysis of variance, so we can calculate any data and compare the data to get better results. So here the presentation of Anova, analysis of Anova. So any question, kindly ask.
Any questions? Any questions? You can raise your hand or write your questions into chat. You know, something to keep in mind is that if you find a crop that really does well, that grows and produces really well in your climate, and you just say, I have a crop that does really well, but you want maybe funding from an international source to help you produce more, if you don't have statistics, they won't believe you. If you show them the statistics of what you did in your experiment, and they want to support you, then they will give you money. But you have to have those statistics to prove what you are saying. That comes from experience and other people who have looked for international funding. Okay, let's go with Tulumun Philip Nombor. Go ahead, unmute your microphone and ask your question.
Good afternoon, good evening. Is Anova important in security control?
Can you repeat your question?
Can we use Anova in security control?
Rabia, the question is, can you use Anova in security control?
Yes.
Are you able to speak, Rabia Liaquat?
Yes.
Yeah,
Security control.
In security control, is that like protecting your borders or for the police?
Like checking the level of security within the country, probably using the police. How safe the people
Actually,
are. Yes.
Rabia, I think you are talking, but we can't hear you.
okay, the question which I understand that if security control point of view, yes, of course, Anova can be used in security control, between two countries. You can compare the security levels. You should have to compete the security of the other countries, and you can calculate the mean of the two countries securities to even two places securities, and you can can you hear me?
Yes, your
Yes.
microphone is muting and unmuting, but we can hear you.
Okay, so you can use Innova to compute the means, average of two actually this is the comparison test. So in for this is not applicable only for one place. You can always compare the security of two places and manage your security according to the places.
Okay.
Yes.
Let's go on to the next question. Sunil. Hari Persad. Can you unmute your microphone?
Hi, good day. Hi, sir.
Hello.
Good day.
Hi.
Hello.
Hello.
I'm Ms.
Hello.
Rabia.
Hello.
Can we use this? I'm not too sure. First, I'm getting involved in Anova, so I'm kind of a bit new to it. It sounds very interesting, and I would like to put it into practice where we do tire maintenance. So, like we have like different variety of different brands of tire. Then in each tire, we have different categories of what you call it, life usage, meaning like punctures, sidewall cracks, bursting, blowouts, different types, different aspects of a failure. So you mentioned about like 1 Anova, 2 Anova, 3 Anova. How you determine again how many Anovas that you use for a situation like that? Can you explain again?
Yes, yes. Okay, in vectors. For example, we have a building of hospital, and if you allow people to enter in the emergency, so this is one factor. But if you specified the female or male enter in the hospital, so this is categorize the situation. So
Okay, something is happening with the sound. But yes, if you're doing tires and you're testing different types of tires, if you get data for each type of tire, you can compare that data. It's that simple. And if you say, okay, we have a tire, we want to check on cracks, and we want to test on punctures, and we want to test on how long the tire lasts, the tread, you get results for each one of those, and you can see, you can compare that tire to other tires to see which tire is the best for cracks, which tire is the best to resist punctures, which tire is the best because it lasts longer, the tread lasts longer. So you can do tests like that with Anova. Anything that you want to compare a couple, like two or three or more different things, and how they produce something, the result of something they do, you can test. Like in security, if you're going to have a festival in the capital city, and it's very important that people come and spend money for the businesses, but you want to know if people feel safe to go there. So you ask the people maybe a couple of months before the festival, will you be safe if we have 200 police present at the festival? Will you be safe if we have 5 police present at the festival? Will you be safe if we have 1,000 police at the festival? And then you get a recording of which answer shows you the best, where people will feel the most safe. And so then you can compare using statistics how different those responses are. If there's no difference, then the size of the police force does not matter. But if there is a difference, then you can show the police chief and say, look, according to our survey here of the people in the capital, if we have 500 police at the festival, that will be, people will feel the most safe, and most people will go to the festival to spend their money. And so that's one way that you can do Anova for like security control. How many police should you have at this festival? And it becomes very powerful because you can also optimize how many police you need. Maybe the difference between 500 and 1,000 is no different. In that case, all you need is 500. You don't need 1,000, just 500, and that people will feel safe enough to go to the festival and spend their money. Okay, do we have another question? You get the idea. If you really want to find out, compare if something is different from something else, you can use Anova. If it's just two things that you're comparing, like if you're saying, okay, we can have 100 police or 500 police, then you can just use a simple t-test. It's even simpler. But if you want to compare, let's say 50 police, 100 police, 500 police, and 1,000 police, well, then you need the Anova because you're comparing more than two groups. And then you can make a better decision on how many police would need to be at that festival. You get the idea, right? Ezra, go ahead. Let me ask you to unmute your microphone.
Please, can you share more light on the calculation formula, Anova formula calculation? Like explain more.
Go ahead and repeat your question.
I said, if you can explain the calculation for Anova, the formula, just shed more light on it, the calculation.
I think we don't have enough time to explain that. We only have about a minute left in this live session. There are YouTube videos and there are books in the AIU Additional Resources Library. You'll see if you go to student resources in your menu, and then you'll see additional resources. Click on additional resources, search for statistics, and then you'll see a lot of books available. And you can just download those books for free to your computer. And they will explain the formula in those books.
Yeah. And
Okay,
you can also ask in the comment section. I will reply here for the formula explained. YouTube section. Any question?
Well, we're actually out of time. We're going to have to stop here and leave it for everybody to think about how you can use the Anova to do a statistical experiment research, to get important data to make decisions, or even to get international funding for your projects. Rabia Liaquat, thank you so much for coming today and presenting Anova. This is a great topic in statistics that can really help a lot of people do research that's very important for their work and for their society.
Thank you so much, and sorry for the connection problem. I don't know why it happens, but sorry. And see the presentation on PowerPoint.
That's okay. We worked through it. We understand Anova is important. We saw what you did in Excel to put down the data.
Yeah.
And then
Yes,
you would produce a chart and then just get the results on a click of a button. So
yes.
that's
And
show how
everything
easy it is.
Yes, and everything I explain in the presentation, you can simply read the things and you will understand very easily.
And then you can just take that graph and those results, paste them right into your Word document for your assignment or for your research paper.
Yes.
Or even into your grant. You're applying for a grant for your particular project. You just copy those results right into your grant application to get money.
Yes.
Okay. Thank you all for coming. I'm going to allow you to unmute your microphones. so that you can all say bye-bye and see you on Monday, same time.
Thank you to you all. Thank you.
Bye.
for this.